Hey everyone! In this short video, I will introduce to you the Linux DRM and KMS driver on MA35 SoC series. After watching this video, you can run modern Wayland client applications with DRM and KMS driver. First, let's take a look at Linux's DRM and KMS. DRM and KMS is a core framework in the Linux kernel for managing display and graphics hardware, enabling efficient and concurrent use of GPUs by multiple applications. It handles the interaction between user space applications and the graphic hardware, including tasks like rendering, mode setting, and display configuration. Here, two abbreviations mentioned are DRM and KMS. The DRM stands for Direct Rendering Manager. It manages the GPU, providing a mechanism for applications to request and access the hardware resources. The KMS represents kernel mode setting. It is a subpart of the DRM framework responsible for configuring the display pipeline of a graphics card. Another abbreviation, FBDEV, is encountered frequently in various situations. The Linux Framebuffer FBDEV indicates a subsystem that provides access to the graphic hardware on a Linux system. It acts as an abstraction layer, allowing software to interact with the display without needing to know the specific details of the hardware. Essentially, it's a way for applications to control what's displayed on the screen. Often, we straightforwardly configure Linux by performing make Linux menu config within Buildroot to enable DRM kernel mode setting. But for MA35 SoC series, you can directly configure Buildroot to enable it. Open the Buildroot configuration menu. In the kernel menu, select Enable DRM in the MA35 series kernel. To ensure maximum compatibility of the Linux DRM and KMS driver, DRM and KMS provides the capability to emulate Framebuffer device. Emulating legacy Framebuffer device with direct rendering, manager DRM and kernel mode setting, KMS allows older applications that rely on FBDEV to run on systems using the newer DRM and KMS framework. DRM and KMS provides hardware-accelerated display output and more advanced features, while FBDEV was a legacy Framebuffer abstraction. Emulation FBDEV involves providing a compatible interface for applications that expect FBDEV, while leveraging the performance and capabilities of DRM and KMS. It is convenient to emulate Framebuffer device through FBTest app and FBGrab within Buildroot. In the Target Packages menu, navigate the Graphics Libraries and Applications sub-menu, select the packages FBTest app and FBGrab. Let's run FBTest in the command line, then launch FBGrab to grab the Framebuffer to an image. Run FBTest in the command line FBTest launch FBGrab to take the screenshot fbgrab-d/dev/fb0 fbtest.png. Let's execute the FBTest rect to emulate Framebuffer now. Run FBTest rect as follows. FBTest rect ampersand. Start FBGrab to take a screenshot fbgrab-d/dev/fb0 fbtestrect.png. Due to the capability of FBDEV emulation provided by DRM/KMS, running Qt5 applications with DRM and KMS is trivial. Before executing Qt5 applications, export the environment viable Qt_QPA_FB_DRM to 1. Export Qt_QPA_FB_DRM equals 1. When launching Qt5 application, append the startup argument -platform Linux FB. Qt5 app-platform Linux FB. When Linux DRM and KMS kernel driver is enabled, LVGL can use FBDEV or DRM as its display backend, src/lib/display backends. Open file lv_conf.h. Set lv_use_linux_FBDEV or lv_use_linux_DRM to 1. By the way, you can fetch the source code of LVGL from the site https://github.com/lvgl/lv_port_linux.git. Let's configure Buildroot to run Wayland clients with DRM and KMS driver. Open Buildroot configuration menu in System Configuration menu. Select Dynamic using dev tmpfs plus udev for dev management menu. In Target Packages menu, navigate the Graphics Libraries and Applications submenu, Select Weston and choose DRM for default compositor. Run the Weston in the command line Weston backend equals drm-backend.so ampersand. Thank you for watching. If you have any question, please contact us.